Okay, so we are working 3.4 section on notes, piecewise functions, and I wanted to look at this document really quick. It's hard for me to go back and forth on this video, not quite, it just doesn't do it right. So we're going to talk about graphing and then also talk about the writing of the equations. So when we talk about graphing, first you're going to make sure that you are you visualize each piece and identify the transformations. Then you're going to use a pencil, graph each piece without considering the domain restriction. So we're going to graph it like we normally do. Afterwards, erase the portion of each piece that is not in the domain. Lastly, you're going to check that you graphed your endpoints of the domain restrictions correctly. So if it's an open circle, then we will use, you'll see a less than or greater than symbol. If it is a closed circle, then you'll see the less than or equal to, that equal bar underneath, or greater than or equal to, and you'll know that's a closed circle. So let's start with the notes. A function that is made up of several pieces from different functions is called a piecewise function. Piecewise function may, so be careful of that, may or may not be continuous. No holes or anything like that, then you know you have a continuous graph. If there's breaks in it or you see a hole, then that is not continuous, okay? So in other words, it may have breaks or gaps in the graph. Okay, so let's look at the first example. Here we have a function, and it says to graph each part, okay, ignoring the domain restriction for right now. So remember, if it bothers you, you can always write this as y equals. No, that's a function, still the same thing. So over here, I'm going to write this first one. I have y equals x minus 2. This is linear. It's a line. Now we can graph these by getting the slope and the y-intercept. Slope for us is a 1, and the y-intercept is a negative 2. So go to your graph and graph that. So again, don't worry about the domain restrictions. So I know that I'm going down to negative 2. Then up 1, over 1 for my slope. Go both directions so you know for sure what you're looking at. Use a straight edge as possible. You will get one on the test, and I'll expect it that, okay? To always have a straight edge. Your ID works, as a matter of fact. So now, according to the written notes that we had over there, we can erase the part of the graph that's not part of the domain. So over here, I look at when x in this one right here, okay, I know x is 1 here, but this graph right here, starting here, and back, it's got to be less than, going this down, going this direction. This part of the graph is what makes that part true. So we erase everything else. So let's erase all of this. I'll get rid of that because that's not part of the graph. And the last thing I need to do is look at this domain restriction and determine, right here, determine what it's supposed to, if it's an open or closed circle. If you look at it, it has an equal to sign. Okay, so if I make sure y'all can read that. It's an equal to sign, so that means I know it has to be closed, and I need to make sure I started it at 1. So I know for sure this is 1, and this is closed. I'll just put it back at the original red color. Okay, if you need to write on the graph, closed or open, because you're kind of a little concerned, that's okay. So now let's look at graph number 2. Graph number 2 is this one here, and that is a quadratic, so it is a parabola-shaped graph, a parabola, and it looks up and down, so that is y equals x squared. This is a quadratic. Now this is our parent function, so you should be able to plot the parent function over here. 0, 0, a 1 and a 1, and don't negative 1, and don't forget 2, 4, and negative 2, 4. And then if we graph it, it goes like this, nice U shape, okay? And then we look at our restriction. We said the x has to be greater than 1. So that means these values here at 1 up to here have to be included. So in the graph. And so that means the rest of it needs to be erased. So do this one's partial. Erase all of that up to the 1. Get rid of that. So now that I have this graph, a little bit better. I know it's here at this point. It curves up. Make sure you see kind of a curve. You need to curve it a little bit because it is a quadratic. You need to see that curve. Now, some of them are maybe straight parts of that, but this part is not. It still has a little bit of curve down there, and it's going up and so forth. So when I look at this, I need to determine open or closed circle. Again, this is less than, so that should be an open circle. So I will delete the little point here and just rewrite it as a open circle. Again, I need to be able to tell that. I'm not going to sit there and judge whether or not you have it open or not. Oops, wrong highlighter for some reason. Because it, it's just not what's going to happen. Okay, that's a big. All right, so like I was saying earlier, if you need to write it, this is open. That's an open. Now, there's more than one way that I will show you how to sketch the graphs. This first way is just using the notes that I airdropped you, and that you draw the graph completely, then you erase what you don't need based on the domain restriction there. So what I will do is, there's also another way, but I'll show you that in a second. So let's go to example number 2. Okay, so now here we have 2 functions. And looks like they're both linear. So the first function is y equals that x plus 1. It's linear, so we know this is linear. This one's linear. There's only x to the first power there. So I need a slope and a y-intercept when I'm graphing this. The slope is 1. The y-intercept is also 1. I'm going to use this information to graph, okay? So I'll go up 0. And then down 1 over 1. This graph is nice because it's got a slope of 1. And then make sure you kind of go out both ways. Connect your dots. And then based on what we read in our that document, was that we had to look at everything that is not part of this graph, which means everything that is not less than 0 here, we're going to erase. So when x is 0, we know that y is 1, so we're going to erase everything this way. Okay, so based on that, what I want to look at now is look at the domain restriction. It's just less than 0, so that means I need an open circle. I'll make this point go away. Create it again, and it should be open right there. So it should be open. Very drastic on that part, just to make sure you see that. Now the second equation we have right here, we have negative 3x plus 1. It's also linear. We have a slope of a negative 3, and we have a y-intercept again at 1. So I'm going to graph this with, I'll do red. So I start at 0, 1. And I'm going to go down 3 and over 1, down 1, 2, 3, over 1. I went the opposite way, it'd be 1, 2, 3, and there and over 1. So look like this. Go straight down. Okay. Now we're going to go look at the domain restriction. Domain restriction says x has to be greater than or equal to 0. So that means I start at 0, when x is 0, y is 1, excuse me. It is right here, okay? Now the thing is, the other one was open, but this one's closed at the same spot. So what's going to happen? It's going to be closed, okay? It will be included, so this whole thing is closed. I'm going to erase the thing that's not greater than 0, which is all of this, right here. Okay, example number 3. This one I'm going to choose to do a different route, another way of graphing. And what you want to do is you're going to plot points and just look at your domain restriction, so you know how to get the extra points and so forth. So I'm just going to go through each one. So I'm just label these 1, 2, and 3. So number 1, if you see it's cubic because we have a cube there. It's shifted vertically up 1 unit, okay? So if I think about what the graph looks like, you can see what it looks like when you're graphing it. And so now here, I'm going to pick values for a t-chart. I'm going to look at this. I'm going to write the domain restriction right here. I'm going to look at this right here. And determine if where I need to start, okay? First of all, when you see that, you will always start at those numbers that are right here, that are next to it. All these numbers, what helps you to start. So this one for us is 0, so that's the first number I'll pick, okay? And then now I want to know another number so I know which direction to go. Well, x is less than 0, so I'm just going to pick the other number on the other side of that, of the 0. Less than 0 is a -1. So now substitute it in to this function here. So 0 cubed plus 1 equals 1. And here -1 cubed plus 1 equals 0. So I have a point at 0, 1, and I have a point at -1, 0. Okay, so I have to look up here to see if I have an open circle or closed circle. Since that's a less than symbol, we know that this right here is open. So at 0, 1, I have a point. 0, 1's here, and it's open. And then at -1, 0 is right here. It's just part of the graph, not open or closed. It's closed, but it's just part of the graph. You don't turn it open or closed automatically. Now what I kind of really do is make sure you see when I plot the actual transformation, everything moved up 1 according to the original function. So this is what the parent function look like, shifted up, translated, okay? So you want to make sure that you have this part of the S that's going down. So if I am less than 0, I'm only going to want that bottom part. Now, I don't expect you to graph these, okay? I mean, the whole graph. I'm just going to use points, but I wanted to make sure you understand, remind me what the actual cubic function looks like, okay? So that's what that looks like. And let's look at the next part. The next part for us is the absolute value, okay? So this one we're looking at is the absolute value, which is the y equals -3 plus 2. Now I did want to make sure that we remember how to use the absolute value symbols and so forth. When you choose your points, okay, one thing about this absolute value graph is here, it has a little, segment part that we can't, it's only going between those two numbers. Those are the two numbers you're going to pick. You're going to pick 0 and you're going to pick 2. Now substitute those two values in for x on the function up here at the top. So it's negative absolute value to have a 0 minus 3 plus 2. Now remember that you have to do what's inside. I want you to think of think of this as the grouping symbols. When you think of absolute value, it is grouping symbols. So that's what's happening here. So you have to do what's inside here. So the absolute value of a -3 is 3, but I have a negative down here, so it's a negative plus 2. So my answer is when I have x and y, when x equals 0, I have a negative 1. That's my y value. Okay. Now put in when x is 2. So if I substitute that in there, I'm just going to see what it looks like. I'm not going to do all the math with it. It's a 2 at the end. So this will be just, if x is minus 1, this is just 1. Okay. Now both of these are closed circles on the graph because of this equal to in this part of our domain. Okay. So let's graph those. So 0, negative 1 is down here. It's a closed circle, and 2, 1 is here. Now this is a segment. It's an absolute value. Okay. Didn't write it, but that's an absolute value graph. So I'm going to make sure that these are connected, and it's a straight, well, it's not very straight, but it's a straight point, a straight line. The next one we're going to do is do the math over here, quadratic. Okay, so the third one we have is a quadratic. Okay, it looks like it shifts up vertically 1, and it shifts horizontally to the right 3. So if you visualize what that looks like. So again, I'm just going to do T-chart on here. And so I'm going to start with 2. Oops. I'm going to start with a 2. This is y. Now, the quadratic, if you remember for the parent function, I want you to have 5 points. I would choose 3 on here because of how much you want to make sure you see if there's the vertex point or anything like that. We know it opens up because it's positive. So it's going to open up, so we're going to have to see if we possibly get the vertex in our domain here. So I'm going to choose 2. The next greater value than 2 is a whole number. I'm just 2, 3, and 4. So I substitute 2 into x minus 3 quantity squared plus 1. Put a 2 in there. Negative 1 plus, squared is 1. 1 plus 1, I get a 2. Okay. When I say x is 3, so it's 3 minus 3 squared plus 1. Well, 3 times 3 is 0. Or 3 minus 3, excuse me. 3 minus 3 is 0. Squared is 0. 0 plus 1 is 1. Okay, and the next one is 4. 4 minus 3 squared plus 1. Well, that's just 1 squared, which is 2. Hopefully you notice this and this, those 2's. That means one thing nice about quadratics, they're very symmetric. So let's graph this at 2, 2. First of all, before we start, 2, this point here has to be open because this is just a greater than sign. So at 2, 2, I'm going to have an open circle at 3, 1, and 4, 2. So you notice I have the vertex here at 3, 1. And it closes up and goes like this. Okay? All right. The next part we're doing is writing equations. And so when we want to write a piecewise function, we want to follow these steps, these tips here. So first you want to write the pieces in order from left to right as they appear in the graph. That's very important because when you start to write your domain restriction, you want to make sure you're on the right side. Use what you've learned about transformations of the base, that's a parent function, base graphs, and or writing equations of lines from algebra 1 to write each of the pieces. And lastly, write the domain for each piece as an equality. Each domain piece should be x or b bounded by 2 values. So if you always looked at them, you either had x less something like this or, less than, but it's always x and some number. When it's bounded by 2 values, that's when you have a number and you have an inequality symbol, an x, and an inequality symbol, and a number. And we'll kind of review that as we draw the other ones. So let's go back to our notes to number 4. Okay, so we're going to write each piece, but first when we do this, we're going to go from left to right. Okay, so we're going to start with this one. So what you want to do is identify it. We know that this is a linear graph. It has an open circle here. Okay, this, by the way, this value is a 4. So what we want to do is we want to write an equation. It must be in slope-intercept form. So for us, we need to find the slope. So if you look, if I go up from here to this one, that's a rise of 1, but I go this way, that's to 4, so that's, I raised it 1 over 4. So my slope is 1/4. My y-intercept is this point here, which is b equals 2. So when I write my equation, it's 1/4 x plus 2. And then what is the restriction? Well, if this is an open circle, okay, so we know it's got to have just a less than or greater than, but we want all the values that are less than 4, and this is going on forever to infinity. So then we're just going to have that x symbol, not two numbers, and then it's going to be what? Less than 4. Okay, next one is this graph here. It is linear, but I'm going to start, when you see these, I want you to think of a horizontal line with an equation. Those are always y equals a number. We don't know what it is, okay? This is closed circle there, so we know it's going to have an equal to with our equal. And it's going on forever and ever, so this is going to be something like this written. So now, if I think about this line, this is a horizontal line. If I extend it out this way a little bit more, I can see where it crosses the y-axis, and that gives me my equation. So this is y equals at 1. So we just put a 1 here. So this is y equals 1. Well, that's already y if you think about it. So here we just put a 1, comma. And then now we're going to look at the restriction. Excuse me, the domain restriction. We know that x has to be greater than, and everything's going in this direction, is greater than or equal to 4. Okay, this is actually a graphing calculator picture that we got off there. So the pixelation, you can still see the shape of everything, but I just want you to know there are no holes throughout this graph. So what I'm going to do is I'm going to highlight them in different colors so I know. Here I see one right here. This first one is going up here, stops there, because at this point, looks like this pops up and goes around. And then we have this last one that goes here. So there are 3 different graphs. So we need to write 3 different equations. This first picture that we have here is a line. It's a linear equation. So we need the y equals mx plus b formula. So we're going to look at it. We need to find the slope, and we need to find the y-intercept. Okay, so now for the slope, look at carefully what you see. I'm going to go down 1 here, and then to the left 1. So if I'm going down and it's a positive slope, you should see that it should be a positive slope. So my slope is just a 1. So now I need to find the y-intercept. We don't see the y-intercept with that graph because, we only want a portion of it. But you still have to write that part because that's still part of the equation. So like we did before, we would graph it and then erase. Well, this was graphed and erased in a sense. So I've got to find the next point, and hopefully I can get to this y-intercept here so I can figure out what that is, if that's the y-intercept there. Well, if I go up 1 and over 1, I do land there, okay? And this is a 2. So my y-intercept is 2. Okay, so now I can write my equation. So my equation is y equals, remember this is your y, the slope is 1, so just write an x plus 2, comma, and everything is included. There's no domain restrictions. Now these type of graphs, if they're from your calculator, know that they go on forever in these directions. The calculator doesn't show you that. So you must understand that's what it's doing. So this is going less than, where do we start? What x value are we starting at? Okay, so let me erase this a little bit so you can see my tick mark there. So here we are starting at this value here, sorry, because it touches the graph there, and that's a -1. So x has to be less than or equal to, and oops, I'm sorry, I wrote that wrong. Less than or equal to a -1. Okay, now let's look at the next part. Let me erase this extra stuff. All right, so my highlighter came off there. So this is this part here. Now this starts right here. That's -1, 2, and it ends here. Okay, so this is actually a 2. So what we want to know is the graph. This is a quadratic. Like it's quadratic. We know that based on what the graph looks like, it doesn't go anywhere horizontally left or right at all. So it's not shifting on the x-axis, but it did shift up vertically 2 units. So we know that it went up 2, so that's a +2. Okay, and we know that it's reflected over the x-axis. So we know that a is negative. So we know we have a is negative. We don't shift left or right, so that's our function equation. And then now we want to look at the restrictions. Well, I wrote already what it started where it ended. So those are your restrictions. And it's all included. Like I said, nothing has gaps or holes in here. So remember, when it's included, you start with the smallest number first. It's always going to be less than or equal to the x, less than or equal to a +2. So the last graph we have here is a line. We talked about one like in the last example. This is a horizontal line which has an equation of y equals a number. Well, what is that number? You kind of sketch where the graph crosses this y-axis. It goes to -2. Okay, so now we know that it's -2. So we just get to put a -2 here. And all we're going to do now is write the restriction. Well, it starts here at +2. The x value here is +2. And it's got an arrow going to infinity, so therefore it's going to be an x and then whatever that inequality is. Well, it's included, so it's going to be greater than or equal to 2. And that's how you write an equation of piecewise functions. All right, number 5, our last part of this lesson, we're evaluating the piecewise function at the given values. So we want to know what the values are. When I substitute a number in, what's the y value I'm going to get out, what it looks like on the graph. So what we want to do is remember that each of these are an x equals. Remember, we know that when I have it inside here, this is x equals -1. I'm telling you what x is. So I need to go to each one and see where I can put that -1 in. It has to be part of the domain. I see a -1 here, but when I put, if I write this as x is less than -1, and I put -1 as my x value, because that's what I said it is, -1 less than -1 is not true. So it can't go in that one. So we're not going to use that. Can't use it in here. Okay. I see another place where there's a -1, or where a -1 might fit, but I know for sure I can see it. It's there. Well, it has an equal to right here, so I know I'm going to use this to find f of -1. So substitute in here, in place of x, you can put -1, that's 0, x squared is 0, and I just get 0 as my final answer. Okay, so now let's do the next one, when x equals 0. Okay, I don't see any zeros, but hopefully you see where it could go. Where is 0 located? Okay, within all this domain. Well, the 0 located is only between this part right here. There's a 0 in there. -1, it's greater than 0. And if you're not sure and you think about it, if I put a 0 in here, 0 is less than -1? No. If I put it down here, is 0 greater than 3? No. So none of those are true. So I know it has to go inside this one right here. Okay? So I'm going to use the same equation. When x is 0, put a 1, add that together, you get 1. Take the square root of 1, and it's just 1. Okay, and our last part, we want to know when x is 3, f of 3. Same idea. Make sure you, again, I do see a 3 here, but if I just do that part with the x, don't worry about the other side of that, is 3 less than 3? No. Okay? 3 has to be equal to 3 in order for it to work, so we're going to put it in this one. So in place of that function, we're going to have 3 squared minus 4 over 3 plus 2. Okay, so we do the math. So this came in here. This one came here. But this also came here. That first one was never used, which is fine. It doesn't have to be used. If we wanted them all used, then we would pick that number, but we did not. So now your final answer for this should be just 1.